All right, guys, this lesson is coming to you to focus on module 3, which has to do with trigonometry. So we're going to focus on the Pythagoras theorem. We're going to try and make this video about um, 50 minutes long. So because we have the trig ratios to work on as well, sine and cosine rule, angles of elevation and depression, and we have bearings. So all of that we have to cover for module 3. All right. So maybe for now we'll just focus on the Pythagoras theorem, and then we will get to the other things in a next session. So what is Pythagoras theorem? So the Pythagoras theorem has to do with calculations that involve right angle triangle, right? Now, what the Pythagoras theorem says to us is that if we have a right angle triangle, ABC, and we know that it's a right angle triangle because we can identify this little box in the corner, which indicate that this side is perpendicular to this side, which means that it gives us a 90 degrees. We can always look at it like this corner of the box, or this little box, this little corner right here, it is pointing to the opposite side, which we call the hypotenuse. So we can think about it like that. So how do I identify which side of my right angle triangle is my hypotenuse? It is the side that this little box is pointing to. So as I mentioned, this little box this little corner right here is pointing to where the hypotenuse is. Now, what do we know about the hypotenuse? One, it is the longest side of the right angle triangle. And two, it is opposite to the right angle. All right, so those are important things to know about the hypotenuse. Now, there are three sides in the triangle, so we can consider this one as side 2, or in other words, in reference to the hypotenuse, it would be side 1, and this side would be side 2. All right. So Pythagoras' theorem says to us that if we have the hypotenuse and square it, it's going to be equal to the sum of the squares of side 1 squared plus side 2 squared. So the length of the hypotenuse, if we were to square it, it is going to be equal to, once the triangle is a right angle triangle, it is going to be equal to side 1, the length of it being squared, and side 2, the length of it being squared. You will often see it denoted as c squared is equal to a squared plus b squared. And one of the things that we want to be conscious about is that the theorem is not letter specific. Yes? The theorem is not letter specific. The theorem is based on how it is written. So if the letters were changed to P, Q, and R, it is a matter of which shape it is dealing with and how it is written. All right. So we not want to think that if the the vertices of this triangle were to change to P, Q, and R or KLM, then automatically then the theorem can't work because we don't have A, B, and C. That's not how it is. The theorem is how the formula is written and not how what letters are used, right? So it's not letter sensitive. So you're going to learn about different aspects of Pythagoras' theorem that, sorry, not Pythagoras' theorem, of a right angle triangle, which will also involve the trigonometric ratios, right? And that we're going to be looking at um, shortly. All right, let us see. I have a worksheet here that I want to work with you on. This worksheet was adapted from mathsgenie.co.uk. All right, so this worksheet that I'm going to be working on was um, copied from their worksheet. So bear in mind, if we're looking at Pythagoras' theorem, it has to do with a right angle triangle. So in this right angle triangle, this little box in the corner is indicating to me that my hypotenuse, this side over here is my hypotenuse, we write HYP for short. So that's where my hypotenuse is. Notice it says find the length of QR to two decimal places. All right, so if we have the hypotenuse and square it, so bear in mind, if we have the hypotenuse and square it, it's equal to side 1 squared plus side 2 squared. So side 1 or side 2 can be any one of them. It is not specific or sensitive to the point where if you use this as side 1 or this one as side 1, it will give you a different result. No, it's not like that. So what we're going to have is the hypotenuse, which is 16 squared, is equal to side 1 squared. Let's use 8 for that one. And then side 2 squared is going to be QR squared. Right? So 16 squared is going to give us 256. 8 squared is going to give us 64 plus QR all squared. So 256 solving for QR. So we'll get 256 minus 64. And then we're going to get 192 is equal to QR squared. But if I'm solving for QR, I need to get rid of the square. The opposite operation of something being squared is finding the square root. So we take the square root of both sides. So if you have the square root of 192, that's going to give us 13.86. And that's going to be the length of QR. So QR to two decimal places is going to be 13.86 and the unit is centimeters. All right. So that's what we would get for QR. All right, let us continue. Now you're going to see this become very repetitive because you're just dealing with Pythagoras' theorem. All right. So you're going to get different shapes and you're going to need to know how to find the hypotenuse or the length of another side. This side over here is the hypotenuse. So the hypotenuse is zy and it is unknown to us. Side 1, we can say it's 1.7 squared plus side 2 is 3.2 squared. All right, so 1.7 squared, that's going to give us 2.89 plus 3.2 squared, that's going to give us 10.24. So in total, we're going to end up with 13.13. And that's zy squared. So to find zy, so it's the square root of zy squared equal to the square root of 13.13. Now this one says the three significant figures. So if we raise to the power of 0, I'm going to get 3.62. All right. So zy is equal to 3.62. This is in centimeters again. We have 1, 2, 3 significant figures. All right, so 3 significant figures. Any queries, you are free to make your notes and ask questions about it. Again, calculate the length of AC. So this side is the hypotenuse. So one of the first things we do when we're looking at these questions is identify where our hypotenuse is. If once we do that, then it makes our lives a little bit easier in terms of setting up the problem. So AC, which is our hypotenuse, is going to be equal to 8 squared plus 11 squared. So that's going to be 64 plus 121. All right. So this is going to give us 185. So now to find AC, so we're going to have AC squared equal to the square root of 185. So the root of 185 is going to be equal to AC, sorry, AC is going to be equal to 13.6. And that is the 3 significant figure. Remember 1, 2, 3. So that's 3 significant figures. All right. So we are to find the length of Ln. This side is the hypotenuse. So if we have 6.3, which is the hypotenuse and square it must be equal to the other two sides. 3.7 squared plus ln all squared. 6.3 squared, that's going to be equals to 39.69. 3.7 squared, that's equal to 13.69 plus ln all squared. So we have 39.69 minus 13.69, and that's going to be equal to ln all squared. So in total, this is going to give us 26. So solving for ln, take the square root of both sides. Ln all squared. So the square root of 26, that's going to give us the 3 significant figure. That's going to be 5.10. And that's ln. All right. And the unit of measurement is in meters. All right, so here it is that we introducing something different. It says we have a rectangle and we have the diagonal, which is AC. So we want to calculate the length of CD, which is one of the sides of the rectangle. So this side is going to be our hypotenuse, because once we identify where our right angle is, the little pointed part is always pointing to where your hypotenuse is. So we can use that as a reference. So it's 17 squared is equal to 10 squared plus CD squared, because they want us to find CD. So even though we have this part of the rectangle over here, it does not play a crucial role in the calculation, because if we didn't have this part, we still could go ahead and do the calculation. All right. So it's not like there is a part of it or there is a number on it that we need to use. All right. So it's not that sort of a thing. It's just a means of using a different shape. So 289 is equal to 100 plus CD squared. So 289 minus 100 is equal to CD squared. So we get 189 is equal to CD all squared. So the square root of 189 is going to give us 13.75. What it says, one decimal place. So we're going to get 13.78. 13.8, sorry. And this is in centimeters, and that's the length of CD. All right. The diagram shows three cities. Norwich is 168 kilometers due east of Lancaster. York is 157 kilometers due north of Lancaster. Calculate the distance between Norwich and York. Give your answer correct to the nearest kilometer. So when it says to the nearest kilometer, meaning to the nearest whole number. All right, so today. So to the nearest whole number. So you're not dealing in any decimals or fractions or anything like that. So this distance that we're looking for here, we can just call that x for right now. That side is the hypotenuse. So that means x squared, which is the distance between York and Norwich, is going to be equal to 157 squared plus 168 squared. Bear in mind that we're finding square root of numbers. While we can, easily work out the squares for the numbers, for some of the calculations, because we're not necessarily leaving the answer in a third form, and some of them, can't just, some of them based on the number, we don't, it's impossible to write them in a third, then you would have to definitely use your calculator to do these calculations. So 157 squared is going to give us 24,649, and 168 squared is going to give us 28,224. So in total, we end up with 52,873, and that is x squared. So to find x alone, which is the distance between York and Norwich, we're going to get to the nearest kilometer. It's going to be 230 kilometers, because the answer is 229.94. So because it's to the nearest kilometer, we round up. All right. So this is not an exact answer now. So when we find the square root of 52,800, and let me just write that. So the square root of it, let's just be clear, is approximately equal to 229.94. So when we round off to the nearest kilometer, it's going to be 230 kilometers. All right. Here we have a television set and we have the diagonal. It says it's a rectangular television. So even though we don't have a little box in the corner indicating that it's a right angle, but the properties of a rectangle is such that we know that the sides are opposite to each other and they are parallel and equal, right? And the angles form in a rectangle. The interior angles, or the sum of the interior angles, is going to give us 360 degrees, with each angle being 90 degrees. So it says that we have a 49 centimeters width and a 34 centimeters height. Work out the length of the diagonal of the screen. right? So the diagonal of the screen in this question is certainly our hypotenuse, right? So the diagonal, we can call that side x for right now, which is the hypotenuse. So your hypotenuse would be right here. So this would be our right angle. So it's going to be equal to 45 squared plus 34 squared. Again, whichever one we use as side one or side two, it doesn't impact the answer. So the sum of these two sides is going to give us 3181. So that's x squared. Solving for x, $31.81. So we're going to get that x is approximately equal to 56.4. What it says to the nearest centimeter, so x is approximately 56 centimeters. So that is what we would get for the length of the diagonal. All right, here we have another shape, question number 8. It says work out the length in centimeters of AM, which is the altitude or the height of this triangle. Give your answer to 2 decimal places. So what we are mindful of is based on the fact that this side is 7 and this is 7, which is two sides of the triangle already. Once we have a triangle with two sides being equal, we know we're working with an isosceles triangle, right? And if this is the altitude of the triangle, then it means it splits the base into two equal halves. So that means this side is going to be 4 centimeters and this side is 4 centimeters. So this side over here is definitely going to be our hypotenuse. So if we have 7 and squared, it's equal to one side, which is 4, plus the next side, which is AM, which is what we're looking for. So we have 49 is equal to 16 plus AM all squared. 49 minus 16 is equal to AM squared. So right here, we're going to get 33 is equal to AM squared. So I'm solving for AM. So we take the square root of both sides because we want AM by itself and not AM squared. So the square cancels with the square root. And if we find the square root of 33, we're going to get 5.74. And the unit is centimeters. So that's the length of AM. All right. Now, bear in mind that one of the things that we try to do each time we're solving these questions is to identify where our hypotenuse is. Once we identify where the hypotenuse is, we can make it much easier to set up the question. So we want the length of BC, which is all of this side. So what we can do is complete the shape to make compound shape. So we have shape 1 and shape 2. Now, this line coming down is going to be perpendicular, parallel to this one and perpendicular to this line. So we're going to have a right angle form here. So that means this side over here is going to be our hypotenuse. Now, if we call this point of intersection here X, it means that from B to X is going to be parallel to A to D. So that means this length is going to be 2.1 meters. Our need, therefore, is to identify what is the length of this side, because this is already 1.9 because it is parallel to this side, and the opposite sides in a rectangle are parallel and equal. So if we have 3.2 square, which is the hypotenuse, it is going to be equal to 1.9 squared, which is dx. And the side that we want to find right now, if we call it y for now, which is from x to c, right, is going to be y squared. All right. 3.2 squared is going to give us 10.24. 1.9 squared, that's going to give us 3.61. And then we get y squared. I'm solving for y squared, or the length xc. So 10.24 minus 3.61, that's going to give us 6.63. I will take the square root of both sides. So we have y is equal to 2.57, and that is in meters. So the entire length of BC is going to be the length BX plus XC. BX we know to be 2.1 plus XC we know to be 2.57 approximated, all right? So we're going to end up with a final answer of 4.67. And that is going to be in meters, and that's the length of BC. All right, meters. All right, so we're almost finished with this worksheet. So this side, hypotenuse. All right, so if we have the hypotenuse and square it, it's equal to the sum of the other two sides squared. We can call this side AB. So we are solving for AB. So we're going to get 81 minus 36. That's going to be equal to AB squared. So 45 is equal to AB squared, square root of both sides. So that means AB is equal to the root of 45, which is going to be 6.71 centimeters approximately, the three significant figures. Hypotenuse. We want to find the length of BC. So BC squared is going to be equal to 10 squared plus 20 squared. All right. So we're going to get 100 plus 400. Sum of them is 500. And 500 raised to the power, find the square root of both sides, BC. So the square root of BC squared, square root of 500. So BC is equal to 22.36 centimeters. Three significant figure. So that means BC is approximately equal to 22.4 centimeters. This is to two decimal places. This is to three significant figure. Number 12 is in like manner. We are to find the length of xy. So this side is our hypotenuse. So we have, sorry, xz is equal to 5.6 squared plus 10.5 squared. 5.6 squared is going to give us 31.36 plus 10.5 is going to give us 110.25. So the sum is 141.61. So that's xy squared. So we take the square root of both sides, xy, square root of 141.61. So we're going to get that xy is equal to 11.9. And this is in centimeters. And that is our answer for the length of xy. So notice the formula, once we get a hang of it, it definitely become repetitive, right? We have a trapezium again, the same way we did the first one, where we, kind of separate it into two shapes. This side is going to be our hypotenuse because this side and this side are parallel, so they are equal. So the entire length from A to B is 9. So if from, let's call this X, from B to X is 3, that means from X to A is 6, right? And this length we don't know, but they're asking us to find the length of A to C. So if we want to find the length from A to C, let me just use something here. So I want to point out something to you. We want to find this length right here, A to C. So in order to find the length AC, we have to first know what this length is, which is BC. BC is parallel to D to X, so that means they are parallel and equal. So if we find the length X to D, that is the same as BC, and with the length BC and AB, we can find the length of AC. So what we're going to do is to first go ahead and find the length BC, which is the same as DX. So the hypotenuse of 10 is going to be equal to AX, which is 6, plus DX. 100 is equal to 36, sorry, plus DX squared. So 100 minus 36 is equal to DX squared, right? So this is going to give us 64 dx all squared. So we take the square root of both sides, 64 square root of dx squared. So we're going to get that 8 is equal to dx. So dx, right? dx is equal to bc, which is equal to 8 centimeters. So with that in mind, we can now go ahead and find the length AC. So AC, which is now the hypotenuse of the triangle, AC is going to be equal to 9 squared, which is from A to B, plus B to C, which is 8 squared. So we're going to get 81 plus 64, which is going to give us 125. So AC squared is equal to 125. All right, so let's continue. So we want to find the square root of, sorry, 145. Sorry about that. 145. I said 125 just now, but it should be 145. All right, let's continue. So we're going to find the square root of both sides. So the root of 145, root of AC squared is equal to the root of 145. So that means AC is equal to 12 point. It says to three significant figure. So to two decimal place, it is 12.04. So you have 1, 2, 3. This is the third significant figure. This 0 is significant because it falls between two non-zero digits. So that means AC is going to be equal to 12.0 or just basically 12. All right. All right. So for a worded problem, we always recommend that you draw a diagram. So you always draw a diagram to represent what the worded problem is talking about. So this is the wall. This is the ladder. This is the ground. All right. So the wall will make a 90-degree angle with the ground. So the ladder then is your hypotenuse. So the ladder is 6 meters long. And the ladder, using the ladder says that the bottom of the ladder must not be closer than 1.5 meters. So this is 1.5 meters on the ground. How far up the wall does the ladder reach? So that means we need to find this side. So your hypotenuse, which is 6, is going to be equal to 1.5 meters. And let's say wall plus wall. And we're going to square it. You can just use that for now. So 36, 1.5 squared, 2.25 plus wall squared. All right, let's leave that for now. So we have 36 minus 2.25, which is going to give us 33.75. Get the square root of both sides. The square root of wall square. So this is telling us that we take the square root of 33.75. We're going to end up with 5.81 meters is how far the ladder will reach up the wall. So as a statement, notice it says how far up the wall does the ladder reach. So we can say the ladder reach 5.81 meters up the wall. So we can just write a statement to answer the specific question that they ask us. All right. So that would be the solution for those 14 questions using Pythagoras' theorem. Right.